Deepinder. I'm the CEO of 75F. You guys probably know that. So let me start with an audience show of hands, since everyone likes raising hands over here. Right? so the thing that I want to ask is, how many of you have ever felt too hot or too cold in your offices or homes? Yeah, that's right. Okay. So my story really starts with your raised hands. So we moved into Mankato. I had a newborn daughter. She was 2 months old. And when she was 1 year old, we moved her into her own room. And we did that. She would actually wake up in the middle of the crying, right? In the middle of the night crying. And I, diagnosis engineer, we figured out that basically the temperature in her room was dropping at night by about 10 degrees. So she would get uncomfortable and she would really wake up in the night crying. So as an engineer, I really wanted to fix the problem real good. Right, so what I did was actually found a company to fix the whole problem. So what I was doing originally was, if you look at that, that's actually, believe it or not, if you're on Verizon, there's a 98% chance it goes over a core network that I did, interestingly, out of my own garage. Right, so I was consulting with Verizon. That's one of the world's first terabit routers in 2006. We actually had to run 220 volts AC to power the damn thing. And it came on a forklift, so you can see the pallet underneath. So, but, and that kept the garage really warm. So my wife's really used to do a nice warm garage. So I'm actually getting it fixed, and I'm going to put a heater in there now. This way. But once we found out that problem that I talked about with my daughter, what our original idea was really to have motorized vents. And if you can see over here, the motorized vent, this one is actually using borrowed parts from a printer, right? And IoT wasn't that hot, at least the term was not that hot back in 2006. So we developed this own 900 megahertz radio system, and you can see that in the background. And what was interesting is, if you see that wireless system at the back, it's got the BCD address that you can set, all very funky in those days. But the interesting thing was, we were pitching to one of the VCs in Tycon back in 2007, and we noticed that basically if you press the damn batteries too hard, they would actually short through and they would actually start heating up, and there would be smoke coming out. so the trick was, take fresh batteries, don't push them in too hard, and then make sure that the VC gets a good look, and then you simply take it away. So those are the secrets, trade secrets. So that's what the lab looked like at that point, right? But the interesting thing is, we formed a company, and that company was called Suntulit. We went on to win what's called the GE Eco-Imagination Award, which is out of 5,000 entries we won worldwide. And at one point, we were talking with GE and Best Buy to commercialize and distribute the technology. Then something happened to the housing market in 2009, and it was no longer such a hot idea, right? So we pivoted. We had a very interesting team. Along the way, we've gathered some interesting folks who've done a lot of good stuff. And right now, we have board of advisors, people like Jay Schrankler, who was president and GM of Honeywell Controls for a long time. Right? So we pivoted, and we decided we want to focus on the light commercial market. And we did pretty well. I mean, last year, we won the Minnesota Cup, and that was a good thing. And then we got an investment from Steve Case, founder of AOL. And then we went on to win what's called the Academy Awards of Clean Tech, right? So we won the Energy Efficiency Division at the Clean Tech Open, exactly where Colin had it. So the easiest way we think of us is Nest meets Sleep Number, right? So essentially speaking, there's a smart thermostat in every room, right? And the target market for us is light commercial buildings. That's buildings under 25,000 square feet. So most of the people so far are really focusing on the big buildings, the Class A buildings. I think the people from Honeywell will kind of attest to that. Or people are focusing in the residential market, which is again a very hot thing. But what we are doing is we're finding this niche in what's called the light commercial markets, which are kind of like residential, but have largely been ignored from a commercial perspective. Right. So most of these buildings have a single thermostat, and that leads to wide temperature imbalances. So occupants who are away from the thermostat are uncomfortable. In fact, one of the building owners we work with issues what he calls a climate stick to his tenants so that they can manually open and close the registers themselves. Right. And the traditional solution to this, and also you waste up energy on like unused areas like conference rooms. The traditional answer to this has been what's called zoning or zone control, which the residential guys from Honeywell probably know. However, it's very, very expensive to retrofit, right? Because it involves cutting into the duct, it involves pulling in all these home run wires. So it's really a pain, it's very disruptive. Right? But what we decided to do was we wanted to make everything relatively easy to install. So what we did is we have 4 main pieces. The first of these is what we call a centralized control unit. So what we chose was the paradigm of an Android tablet. So we took a Google Nexus 7 and we customized the hell out of it. It's running a custom ROM, hardened ROM, so it's only running our apps. But that allows you to do development in a paradigm which is much easier than the embedded control system that everyone used to. Right? So you don't have to take care of the visualizations. I mean, all these high-level parameters are always already available to you. So we use that, and then we did custom electronics at the back end to actually interface with the rest of the sensors. Right? People keep talking about the hub and stuff, but this is really our version of a gateway. And that's what we've kind of stuck with. So what I'm going to do is, and the second piece that we have, and this goes and replaces the existing thermostat which is in the building. Right? So what we do is you replace it, and it's got the relay context for turning on off your HVAC equipment just like your thermostat would. The second piece that we have is this room module. Right? So I'm going to actually pull it off over here. So this is a room module. This actually goes in the walls. The paradigm that we chose was what's called this old work junction box. So you can stick it into the wall, cut a hole, put this old work junction box. It's actually used for electrical sockets. So essentially this goes in flush, so it actually has very little profile sticking out. Right? So it goes and matches the decor of the room. So we measure the temperature and we allow the temperature to be set as well. So essentially speaking, it's like a thermostat in every room. And the third piece is what we call a smart damper. So this is what it looks like. It's a radial damper. So the air that comes into a room comes out of what's called a diffuser. So these are big, large linear diffusers. You'll probably have some smaller ones in a commercial building, square ones. So what we do is simply pull down the diffuser, slide in one of this into the ductwork, and you can hold it in place with a small 2-sheet metal screw. So you don't really have to cut into the ductwork to do this. Right? And then you run a small cable from this damper to your room module. So I'm going to put it here. Clip. And power. So the first time it actually goes through a calibration cycle, it figures out what kind of this room module actually detects what kind of a damper is attached to it. It'll figure out its characteristics and so on and so forth. And so far, what I've shown you guys is not something new. I mean, we are in the IoT space, everyone does it. It's all what I call de facto accepted these days, right? It's cute. But the real interesting thing is, this is where things get really interesting. What we do is we take the temperature which is coming in from different parts of the building and we load it to servers in the cloud. Every night we crunch this historical data and we actually create a thermal model of the building. So we figure out how the building is going to be behaving the next day based on the forecast weather. Right? We then figure out an optimal control strategy to control the HVAC equipment. And we send that back into the centralized control unit, back over here, and this guy proactively controls and modulates these dampers during the day. Right? The results are what we call dynamic air balancing. So the system constantly learns and adapts to changes in the weather and the heat loads. If we were to think of like, why do these temperature drifts occur? Right? It's not just our imagination. What ends up happening is in the morning, you have different heat loads in the building. In the morning, the east side gets more solar gain. Right? So that's going to rise up in temperature. In the later part of the day, the west side gets more solar gain, so that rises up in temperatures. But when you set up your HVAC equipment, it's always set up for a static set of conditions. What you really need is to move that air to different parts of the building based on where the loads are. And that's exactly what we do. We figure out a way of creating a thermal model. We figure out what the heat loads are going to be, and we shift the air where it needs to go before those temperature errors actually occur. And that's one of the key things is that, I mean, what we are really doing is we are being very proactive. Most control systems are based on the PID system, right? PID loops and so forth. But basically, PID is reactive. There's very little forward-looking aspect to most control systems so far. So essentially speaking, if you have a light bulb and you detect someone's in the room, you turn it on, it's perfectly acceptable. But if you detect that somebody is in the room and you turn on the heating, it takes too long, right? It takes 20 to 30 minutes before the temperatures are going to rise up. By that time, someone's moved on, and if it were my wife, my system would be out in the trash. Right? So essentially speaking, what you have to do is you have to have these predictive algorithms that figure out what is going to occur ahead of time, and then make appropriate action, take appropriate action. So the way I look at it is that basically speaking, if you were going down the road and you were looking in your rear view mirror, it makes for a really bumpy ride, right? But if you look at the cars coming ahead of you, half a mile up, you make these very small subtle adjustments with your steering wheel, right? So that's exactly what we're trying to do here. So it's always, IoT is very ubiquitous these days. I mean, overall, platforms have evolved, sensors have evolved, the cost of sensors are going down. But ultimately, the key message is that, I mean, what you really need to do is work on the software and the application, right? How do you ensure that what you're producing creates value, and that value really lies in understanding behavior and modifying that. Right. So I mean, just like compilers were ubiquitous, I mean, that's what we look at. I mean, the sensor networks themselves are ubiquitous now, right? I mean, it is no longer a big deal to say that I can control a light around the world using the web. Right. Yeah. Cool. So with our system, we end up with far more even temperatures, right? And the key is that we incorporate things like demand control, ventilation, occupancy detection, multiple strategies that combine to save over 40% in energy savings. Right? And so far, energy saving has always been the bitter pill. Typically speaking, you are asked to turn on the thermostat, do the laundry in the middle of the night, or do something which is uncomfortable. So that's what you associated. What we are doing is taking this bitter pill and turning it into something more palatable. Right? And that's really the key, is that, I mean, all of our power should be used to make things which are easier to use. I mean, so far, many of the things that we associate with IoT are making things controllable from a smartphone, right? Changing the temperature from a thermostat from a smartphone is a good first step. But if you have 100 thermostats, or if you have 100 lights, I mean, it's geeky for the first few days, but then it gets old pretty soon. So what you really need to do is automate it and make sure that this technology works in the service of the people, rather than actually being something which consumes a lot of time. Okay. So that's why we say we want to make energy conservation something which is far more palatable, because the way we put it is that saving energy never felt better, right, with our system. So I'm actually just going to leave it up at this point and open it up for questions. Yes?
You mentioned that you do occupancy detection. How do you go about that?
Oh, it's a motion detection system actually.
So how do you go about adjusting the temperatures based on, so I mean, do you actually learn the motion patterns as well?
It's a great question. I mean, it's a very long answer. So when we started we were looking at the residential systems. At that point, we actually have a patent on using infrared thermal profiles and figuring out whether it's a human occupant or something like a pet, right? But at this point, in the commercial environment, we don't expect that interference. So we actually it's much cheaper to use a PIR, passive infrared sensor, and that's what we're using for motion detection in the commercial thing. Go ahead.
Have you ever looked into using air quality sensing for outside control for occupancy detection?
That's fantastic. We do that. That's very, very important to us. That's integrated. We call it demand control ventilation. So we actually look at the CO2 levels, and we get an fresh outside air based on the CO2 levels within the building. We also do that for things like conference rooms and stuff, where we can actually put in a dedicated CO2 unit. So, and that's a leading indicator of the number of people within a room, even before the temperature rises. So we can use that within the algorithms as well. So great. Yes.
Can you do secondary level things like scheduling a conference room? If you know this day it's not used until noon, but this day it's used all day, you can plan ahead?
Absolutely. So we're working on that API with Outlook, and we're also doing that for hotels as well, for reservation systems.
Can you install in a building that uses a vacuum system?
We do it as a retrofit. So pneumatics, if we retrofitted the entire system, we would take over that, and we've done that successfully in some places. We've also done it for what's called DAV, the old style zone control systems,
Yep.
so we've done the retrofits for those, but we don't interop with them, right? So there's no way of doing half pneumatic and half our system. And
How do you go to market?
we slug it out. So we actually go through the old channels. It's a two-step channel distribution. We go to HVAC distributors, HVAC contractors, so on. And that is important to us. That's the path we've chosen. It's not a B2C at all, it's B2B.
So when you get a building that's going to be retrofit,
Sure.
do you how do you implement the actual? Do you charge like an NRE cost to plan it out, or is that all free? I mean, how does it actually get designed?
And that's a very interesting aspect about this. I mean, see, one of the things is if you were to look at, let me just pull this something up. This is a good point. So if you were to look at why control systems and HVAC specifically are so expensive, is because basically they're like Lego blocks, right? And it really takes, and they're very, very versatile. It takes a Lego master to come together, put all these blocks together and make a bespoke solution, right? And that is why they're typically restricted to things like your Class A buildings, your buildings in downtown Minneapolis, which all of them are different, so you require a solution which is different. What we have really done is our install itself, all it really requires is putting in the address, and then we use Google Maps to figure out the location, fin, lat, long, orientation of the building. So you put in the Wi-Fi, put in the address, register, and you walk away. So that whole piece that you're talking about, configuration and the controls aspect, all of that has actually been abstracted and put into the software. So the install cost is much radically cheaper than a traditional control solution. So the materials cost is probably about what it would cost from another current Class A vendor, but overall the install cost and the fact that it's wireless, you don't have to pull these wires, makes a relatively bigger impact. Okay.
It's been like working with Steve Case.
It's great. I mean, it's been a fantastic opportunity. They have really put us up front. I mean, not just in terms of the money itself, but we've had opportunities to present at South by Southwest. We recently went to Google. We were there for Google Demo Day. So that was fantastic. And what was interesting is we actually hired a plane pulling a banner, and we buzzed the Google headquarters while we were presenting for 5 hours. And they thought, Google said that's the most dramatic entry they've ever seen in the Google Demo Day. And Steve Case said, that's pretty ballsy of you guys to come and buzz Google, who's just bought Nest. Yeah, go ahead.
So yeah, I just have a good idea. So I was thinking if you change the font to the shutter, so you can actually close one of the heat
Yes.
coming out, well, that'd be much cheaper to make and work pretty much the same.
You're absolutely right. I mean, that's the key is, I think everyone's trying these things, these more integrated solutions as we go on, right? So I mean, we started with HVAC because that is one of the core, that's where most of the energy is spent, right? 50% of the energy in any building is spent on HVAC. So we started with that, but now you start going into the more integrated, funkier solution.
It's actually much easier. Just think about if you shut one out.
Right, I understand.
The airflow is going to go to different directions, so it still works the same way, right?
Right. Okay. So you had a question, sir?
So how long does it take your analytics to learn basically the thermal profile, and does this get updated from winter to summer?
Right.
So I mean, how long does it take for the steady state of your thermal profile? I mean, so you can do well to predict.
7 days. Right, and we keep updating it every night. So we don't. Right, and we don't have any trailing history, so every night it gets updated. Right. And
Is there any recurring revenue that you get from these installations?
right, we do. So there's a subscription service associated with that. Because we do proactive, it's not just, we do the alerting pieces like Colin and gang do, I mean, and there's also, so we can also look at the performance of the rooftop unit itself. We can say, hey, we have told people the refrigerant charge is too low, go take a look at it. We can look and identify problems in the ductwork. So there's a lot of opportunity for the contractors to upsell and say, the existing building has bigger problems than you knew. There's insulation issues, so on and so forth. So there's big data analytics involved all the time.
Plus you have seasons, right?
Yes, absolutely.
Do you have controls on the main intake ductwork for the building also? Do you help manage the pressure differences between outside and inside?
Good question. We actually do enthalpy economizing, so we don't look at pressure. I mean, most of the buildings that we're going into light commercial, right? So you would not have that big pressure changes that you would normally see in a high rise, right? I mean, so these are low pressure systems. In fact, we've actually gone into buildings which have actually no return airs, right? So, or no outside air either, or equalization, and they still work. So, I mean, this is really relatively lower tech stuff. Smaller buildings get by with a lot more crap, I guess. Cool. Questions? Yes.
So that was mine, but my last question then is, so how's the baby? Is it working?
Yeah, the baby is now 8 years old. It takes a long time to develop this stuff.